All right, last class we talked about the piecewise definition of the absolute value of x. Remember this? Okay, what was the definition? The absolute value of x is equal to
X is greater than or equal to 0.
x. And
Negative x if x is less than 0.
If x is less than 0. Okay. Right, this expression depends on the value of x. It's either x or. What would be this? The piecewise definition of this. It's very similar. It's either going to be x minus 3 or negative x minus 3. Is this true?
Is it greater than 3?
Good. X is.
Because x minus 3 needs to be above 0, so it should be greater than 3.
Yeah, but then it can, yeah, at least have it 6.
Okay, there's some different discussions going on. Is this true?
Oh, it's a
X can't, because if it's.
But let's pretend this is true. It's not. If I plug in 0 here, that's negative 3. That becomes 3, right?
Yeah.
But 0's here. If I plug in 0 here, you get negative 3, which is not correct. Okay, so this is the way we do it. It is equal to this. If not x greater than or equal to 0, if the whole inside is positive or 0. So we write if x minus 3 is greater than or equal to 0. And if x minus 3 is less than 0. Okay. And then x minus 3. And you could either leave the negative on the outside or go distribute it. Negative x plus 3. And then for each of these, let's solve for x. So plus 3 if x is greater than or equal to 3. If x is less than 3. Okay. So this is the piecewise definition of this absolute value expression. Absolute value of x minus 3. The key is when you set up the inequality, you just take the entire inside and set the entire inside greater. So the absolute value of 2x plus 4 is going to be 2x plus 4 or negative 2x plus 4. So it's 2x plus 4 if 2x plus 4 is greater than or equal to 0, or if 2x plus 4 is less than 0. We get 2x greater than or equal to negative 4 divided by 2. And x is greater than or equal to negative 2 if x is less than negative 2. Make sense?
Yeah.
Try this one. It's gonna be a little bit different because when we solve the unify, you're gonna have to divide by a negative to flip the sign. So try this one on your own. When we divide by -2 here, gotta flip. You get that?
Yeah.
Okay. Okay. Oops. What is this thing I've written down? An equation. Is it true, false, or
Open.
open? Are the solutions numbers or ordered pairs? Ordered pairs. Because
There's two variables.
two variables. This is a absolute value equation, two variables. Is it also a function?
Yeah.
Definitely is. You can plug in any number for x and get up one y value. So we call this absolute value functions. Okay. The solution set is going to be a bunch of ordered pairs. We're going to graph the solution set. Okay. In order to do this, we have to break it up into its two cases. Okay. Well, let's break it up into its piecewise definition. And what is the piecewise? Okay. So this has two different pieces. The first piece is y equals x if x is greater or equal to 0. And the other piece is y equals -x. Okay, these are both linear functions. What's the slope of this one? 1. And what's the y-intercept?
This is 0.
0. There's nothing here. Okay, so it's this line right here. With the slope of 1, y-intercept is 0. Except this is only true if x is greater than or equal to 0. So we have to erase everything to the left of 0 here. So we erase all this guy. And then this guy is also a linear equation with a slope of -1 and a y-intercept of 0. Which is that line, except it's only true when x is less than 0. So we got that. It's only true to the left here, so we erase all of these. Okay. this left one does have an open circle right here because it's not true. However, it's already filled in that point for with this function. So we don't put an open circle there. There we go. And there it is. That's the graph of the absolute value. This it looks like it's a V looking thing with the slope on the right of 1 and slope on the left of 1. Okay. This is the solution set. This is the graph of this very important function. Did you guys graph these last year?
Oh,
Okay, yeah. So absolute value is a type of piecewise function. But okay, let's try another one. Sure, let's go with that.
Just to be that's my
Okay, let's write the piecewise definition. So it is x, no, it is x plus 3 if what?
X is greater than 2. Negative.
If x plus 3 is greater than or equal to 0. And is negative x plus 3 if x plus 3 is greater than or equal to 0.
what?
What?
Oh,
Okay, then we subtract 3 here, subtract 3, subtract 3, subtract 3.
the same equation. Which one? Like x plus 3 is greater than 0. The other one
Yeah,
is
just
x plus 3.
the inequality sounds the same.
Oops, this is supposed to be less than, right? Is that what you're talking about?
Yeah.
Thanks. So now we got two different equations. One is y equals x plus 3 only if x is greater or equal to 0. And we got y is negative x minus 3 if x is less than 0. Okay, this is a linear equation with the y-intercept of 3 and a slope of 1. Okay, but only if x, did I write 0? Geez. If x is greater than or equal to 3, negative 3. If x is less than negative 3. So here's negative 3 right here. It's only true when x is greater than or equal to that number. So we erase everything here. And then this is also a linear equation with a slope of negative 1, y-intercept of negative 3. But we got to erase everything or keep it only when x is less than negative 3, only here. So we erase all this. There we go. How does the graph of this guy compare to the graph of this one?
It moves to the left.
This moves to the left by how much?
3.
3 units. Okay. What did we call last year when we moved?
Translation.
There's a type of transformation called a translation. So we translated this function, y equals absolute value of x, to the left by 3. Okay. And how can we tell that from here? Oops. Did you guys do many transformations last year of actual functions? Okay. That's okay. So the only thing different, our previous one was y equals absolute value of x, right? So when you replace x, with x plus some number, let's call it a, or let me just go with 3. It just takes this function and shifts it, everything left, the opposite of that sign, so if it's positive, it goes left by 3 units. Okay, we're going to do lots of transformations of functions. I'll come back to that. This little point right here, called the vertex. I don't know if we learned that last year. Okay. So here now the vertex is at -3, 0 instead of 0, 0. All right, let's try another one. Okay, let's do its piecewise definition. It's going to be x minus 2 minus 4 if the inside x minus 2 is greater than or equal to 0. This could be negative x minus 2 minus 4 if x minus 2 is less than 0.
Why wouldn't you move the 4 over to the other side?
We always want y by itself. You could, but then it gets super complicated. Okay. Right, so this guy right here is this piece and this piece. Or not piece, but the expression. And then the minus 4 just stays on the outside. And now let's add 2 plus 2 plus 2 plus 2. And then let's combine like terms here. We get x minus 6 if x is greater than or equal to 2. And negative x plus 2 minus 4, is that minus 2? Less than 2. So again, we got 2 different pieces. One is y equals x minus 6. X is greater or equal to 2. And the other piece is y equals negative x minus 2. X is less than 2. Again, each piece here is a linear equation. With the slope of 1 and a y-intercept of -6. Uh-oh, it's way down here. Except we need, it's only true when x is greater than 0, so, sorry, greater than -2, so we erase this part. Ah, this is a y-intercept of -2. That's something like that. Okay, so compared to our function y equals the absolute value of x, what did the replacing x with x minus 2 do to it? Right, this was y equals the absolute value of x. It moved it to the right or left? Right by 2. Like this. And then what did -4 on the outside of the function do?
Move it down 4.
Moved it down 4. Okay. So the new vertex is at was it 2 comma -4. Okay. And is that always going to happen when we have x plus or minus a number? It is. You can immediately look at this. You know where the vertex is. It's always the opposite of that number, comma that number. So it's going to be -2, comma 4. Or in other words, sorry, -4. 2, -4. So we're actually going to graph these much faster without doing all the piecewise definition. We're just going to find the vertex and then figure out what the slope is. And what is the slope of this guy? There's no coefficient. Or the coefficient's 1, and there's no number out here at 1. So the slope's going to be 1. So once we find the vertex, we just know we go to the right, go to the left. Okay, so the piecewise definition, it's either going to need to be 2 times x minus 4 if x is greater than or equal to 0, and 2 times -x minus 4. So these are both linear equations. Y-intercept of -4. But now the slope is 2. So we rise 2, run 1. Rise 2, run 1. Oops, that's the green one. There it is. So still a V, but it's the slopes are changed. Okay. This is another type of transformation. What do we call this type of transformation? So it definitely translated down by 4. Did it translate left or right? No, because there was no there was nothing it's just the x inside the function. It translated down by 4. What did the 2 do to it?
Change the slope.
Definitely changed the slope. But what kind of transformation does that call?
Dilation.
A dilation. Okay. Sometimes we call it a stretch because we're only dilating in one direction, only in the y direction. So it actually, like if we took y, well, y equals 2 without the minus 4, it takes this function and multiplies all the y values by 2. So it moved up here. This one moved up to 4. It stretched it. Okay. And it stretched it. And then we graph that and shift it down by 4. Okay. So, okay, let's not even write the piecewise definition. Let's just use transformations. This determines left or right, replacing x with x plus 1. So what does it go?
Left.
So the opposite of that number. So it goes left 1. So we're going left 1 unit. What does the minus 2 do?
Down 2.
Down 2. And then what does this do? Stretch 3. And with linear equations, stretching by a factor of 3 is really just changing the slope to 3. Okay, so it stretches 3. Okay, so the old vertex 0, 0 of y equals absolute value of x is only affected by the left and the down. So this is going to go to -1, so left 1, and down 2, -2. So this is our vertex. And then for absolute values, this determines our slope. It's going to be 3 and -3. So when we go to the right, we go up 3 over 1. Up 3 over 1. Then to the left, it's going to be up 3 left 1. So we can graph these quickly with transformations if you understand each part and how it affects it. All right, let's try another one. So the x minus 3 is going to shift everything right 3. So 0, 0, our vertex goes to 3. And then the plus 1 does what? Up 1. So instead of a 0, 0, it's going to be 3, 1. is our new vertex. And then what's our slope going to be? Our slopes are going to be 1/2 and -1/2. So rise 1, run 2. So the 1/2 actually, instead of stretched it, compressed it by 1/2. Or say it stretched it by a factor 1/2, which means it compressed it. And there's the quick graph. Where's the new vertex going to be? It goes to the right by 3. So 3, and there's no number on the outside, so it's not going up or down. So 3, 0. How is this negative going to affect it? Right? The opposite of a function just takes all the y values and makes them the opposite. It's a reflection about the x-axis. Okay. So if we broke down the piecewise real quick, let me just do it. You don't have to write this down. Be -2 times x minus 3 if x minus 3 is greater than or equal to 0. -2 times negative x minus 3 if x is less than 0. If I simplify that, okay. So to the right of 3 is the part that has the negative slope now. To the left of 3, it has the positive slope. Okay, so it's going to do this instead. Okay. So the negative coefficient of simply makes it an upside down V instead of a regular V. Where's the new vertex going to be? The opposite of that, comma that. -2, 5. Oops. And then the slopes are going to be 4 and -4. It's going to be an upside down V or a regular V? Upside down because of this negative. So let's go back up. Okay. And we didn't need to write any of the piecewise definitions to figure that out. Once you know where the vertex is and how this affects the slope, it's easy. Sound good?
Yeah.
Okay. Now, what's the equation?
2x y equals 2.
Okay, so what's the coefficient in front of the absolute value going to do?
2.
It's going to be 2. How can we tell?
Because it's positive. And it's
Rise 2, run 1. Okay, is it positive 2 or negative 2?
positive.
Because the v is going up, it's definitely going to be positive 2. Times the absolute value. And we went left 3, so we go x plus 3, or x minus a negative 3, and then we shift it up by 1. That's it. That's cool. Any questions on that? Does this make sense?
Yeah.
All right, let's try another one. So the slope is going to be, so rise 2, 1, 3. Definitely negative. If the v's down, negative 2/3 times the absolute value of 1, 2, 3, 4. X minus 4
Plus 2.
plus 2. Easy peasy.